Hello and welcome to the 1.2 topic 1.2 notes, segments, lengths, and midpoints. Here we go. A couple of vocabulary words. First thing is a postulate, also known as an axiom, and it's something that's accepted without proof. If we were in class, we'd go through all sorts of questions on this, like what is something that's accepted without proof? And really it's like the most important things in our lives, like big conclusions, like do aliens exist? Some people think that they do, some people think that they don't, and there's no proof either way that they do or they don't exist. It's just something you assume is true. Alright, and so there's all sorts of things that we assume are true. In geometry, we have postulates, things that we assume. Like, for example, what is 11 plus 2? Right? It's 13. Believe it or not, there's an assumption here that we're not questioning. It's an assumption, and the assumption is that the number line continues forwards without circling around on itself. But so this is true under the assumption, under the postulate, that the numbers go 1, 2, 3, 4, 5 and they continue forever. But under a different assumption, like let's say the number line circles back on itself after 12, like a clock. So if it's 11 o'clock and until you meet me in 2 hours, 11 plus 2 is 1. What is the correct answer for this problem? Is 11 plus 2 13, or is 11 plus 2 1? And it depends on your assumptions. What assumptions is driving your truth? So a postulate is anything that is assumed. Okay? So actually geometry is built on assumptions. And there's actually different types of geometry that work on different assumptions. We're doing what's called Euclidean geometry, which uses this assumption. So this is true in Euclidean geometry. Okay, so there's other things that we'll talk about. Congruent segments. Congruent means same measure. That's what congruent means. Same measure. Two segments with the same measure. So over here, we could say that segment AB is congruent, and this is the symbol for congruent. It's like an equal sign with a little squiggly. Segment BC, right? This segment is the same as this segment because they're both 5 centimeters in length. They have the same measure. We can mark that on the diagram with 2 little tick marks like that. So put in a mark means that this is the same as this. That's the congruent symbol. Distance. The distance from points A and B. In this picture, the distance from A to B is 5 centimeters. The distance from B to C is 5 centimeters, thus making them congruent segments. Distance is the same as length. So I might ask you to find the distance, I might ask you to find the length. It means the same thing. The length of a segment with endpoints A and B written as AB. Now notice here, there's no symbol above. There's not a ray, there's not a segment, there's not a line. When there's nothing above 2 letters like this, that just means AB. And we can state that the length of A to B is 5 centimeters. So nothing above that. It's kind of picky. Midpoint. A midpoint is a point of a segment, is the point that divides a segment into 2 congruent segments. So now that we use this word congruent, I can now use it to make bigger words. I'm building off congruent to make a new word midpoint. I'm going to build off midpoint to make a new word segment bisector. So B is a midpoint of segment AC. Up here in this picture, B is the middle of segment AC. It's the midpoint. A segment bisector, this word bisector shows up quite a bit. A bisector is anything, it could be a point line plane, that goes through the midpoint. Alright? To bisect means to cut something into equal pieces. So if I were to bisect a person. That's not a very good person, but you get the idea. If I were to bisect a person, would I cut it there? That wouldn't be bisecting. Bisecting means cutting it into two equal pieces. Equal pieces, okay? You're going to cut it down the middle, and this side is the same as this side. Two equal pieces. Okay, next. Write the notation. So all about the notation now. This is a summary of the notation that we'll use the rest of the quarter. Alright, so first thing is the line that goes through points A and B. Here it is. There's a line. It's got an arrow that way. It's got an arrow that way. We call this line AB like that, with two little arrow symbols. Next is segment. So that's just including this part. It does not go. We'll call that segment AB like that. It has endpoints AB, so that's the symbol for that. The ray that has an endpoint A, so that'd be this ray right here. Starts at A, goes through B. That's how I'd write that, ray AB. Whereas the ray that starts at B and extends through A would be going this way. It started at B and it go through A. It's different. So we would write that like this. It's different. These are two different ways of writing that. And then lastly, the distance from A to B. And remember, distance, you don't use any symbols. You just write AB. So those are the symbols that we have so far. Line, segment, ray, and distance. Okay, next. Segmentation postulate. This is a postulate. This is an assumption. We're assuming that this is true. And it might not be true under different assumptions. So like for example, we're assuming that 11 plus 2 is 13. That's kind of what we're doing here. We're saying that it doesn't come back on itself. That's the assumption. For example, if the length from A to B is added to the length from B to C, and here's the picture, if I take this length here and add it to this length here, I get a total of A to C. That is, A to B plus B to C is like going from A to C. You take two parts and you make a whole segment. Alright, so easily we can do this. 18 plus 4 is 22. If I take 18 and add it to 4, I get the entire length of 22. This one's a little bit more difficult. By the way, the answer was 18 there. Now we're looking for QS. So find the length from Q to S. Well, what do you think? Pause and figure it out. If this is 19 from P to S, and this is 15 from P to R, I would say that this piece here must be 4. Because 4 plus 15 is 19. And then if this whole thing is 19, this has to be 9. Because 9 plus 6 plus 4 is 19. And the length from Q to S, the length from Q to S is 10. Right. So just segmentation postulate, we can add things together. Alright, next. Here's a sentence, point B is between A and C. You're going to have to know how to draw that picture. So that would look something like this. Point B is between A and C. B is between A and C. And I'm going to go in and label. I'm going to label these pieces. So segment AB has a length of 13 plus 2x. So this piece here is represented by 13 plus 2x. The length from B to C is 12. And the entire length is x plus 32. So how do we write these together? Does it make sense now that this plus this equals this whole length from A to C? A to B plus B to C equals A to C. So here's the equation. The equation looks something like this. 13 plus 2x, so this piece plus this piece. So if I add these two pieces together, it should equal x plus 32. There we have it. That's our equation. I've got my two pieces, and it adds up to the entire length of x plus 32. So now do your algebra. 13 plus 12 is 25. Subtract that x over. Okay, so subtract that x over. So that's 2x minus x. And now subtract the 25 over. When I subtract 25, 32 minus 25 is 7. Alright, now what you can do is you can check your work. Let's go plug in 7 and see if this diagram makes sense. So 7 plus 32 is 39. Okay, and this is 12. So these two pieces, when I add them together, has to equal 39. So if I plug in 7, 7 times 2 is 14. 14 plus 13 is 17. Does 17 and 12 make 39? Yes, it does. So that means that we did this problem correctly. X is 7. And we found all the pieces. It says solve for x, write an equation in terms of x, then solve for AB, BC, and AC. So we found all the pieces. It all works out. 17 plus 12 is not 39. This is 27. Still silly, Mr. Smith. 27 plus 12, that's 14 plus 13 is 27. 27 plus 12 is 39. Okay, it happens. But by checking my work, I was able to find my mistake. Next, this one's going to be just a little different. Same setup. You have A, B, and C. Oh, by the way, was this diagram drawn to scale? Because in my picture, this piece here looks shorter than this piece, but in reality, this is 27 in length and this is 12 in length. And that's okay. This is just a picture to help us get the equation. It's okay if your picture's not to scale. Don't expect pictures to be to scale. Alright, let's label the picture. It says A to B is x squared. B to C is 8x. And the entire length from A to C is 20. So now pause the video and make an equation in terms of x. Here's our equation. The equation is that piece plus that piece equals the entire length of 20. Now this is a quadratic, something that you should have learned in algebra, how to solve a quadratic. When we're solving a quadratic, whenever you see an x squared, that's a quadratic. When you solve a quadratic, you have to bring the 20 over so that it's equal to 0. You have to solve quadratics such that they're equal to 0. It's step number 1, make it equal to 0. Step number 2 is factor if you can. So take like that, but we can't. Step 3 is you, this is also called factoring. You do this thing. So if you can remember, you look for two numbers that combine to 8 and multiply to negative 20. Add to 8 and multiply to negative 20. Can you think of two numbers that add to 8, combine to 8 somehow, and multiply to negative 20? That's right. Positive 10 and negative 2. What is 10 minus 2? 8. What is 10 times negative 2? Negative 20. Those are the answers. But that's not the answer yet. Remember, we're trying to make this equal to 0. So does 10 plus 10 equal 0? No. Negative 10 plus 10 equals 0. So that's one answer. And the other answer is 2. 2 minus 2 is 0. So we have two answers for this particular problem, and that's good algebra, is to get two answers for a quadratic. That's what you want to get. However, in geometry, we need to think about this. If I plug in negative 10, that makes this 100, right? Negative 10 squared is 100, and it makes this negative 80. Now, 100 and negative 80 does make 20 when I add them together. However, have you ever seen a negative length? No. There's no such thing as a negative length. That's silly. You can't have a negative length. So then we need to cross that answer off. That's not a possible answer. It works algebraically, and it does make 20 when you add them together, but it doesn't make it. You can't have a negative length. Let's try 2. 2 squared is 4. That's one of the answers. 2 times 8 is 16. Does 4 and 16 make 20? Yes, it does. Alright, the nice thing about geometry is that you can always check your work. It's wonderful. Number 4. Now we're going to deal with a bisector. What's a bisector? A bisector, remember, it cuts things evenly into two equal pieces. So we're under the assumption now that this is a bisector. And you can see in the picture that this piece here is congruent to this piece here. Now because they're congruent, that means they have the same measure. Which means we can write an equation. We can use the word equal. We can say that this side is equal to this side. So that's why we can use an equal sign. And then from there it's algebra. So add your 2 over here. I like to keep things positive. Take this x and subtract it from 8. 8 minus x is 7x. Take your 7 and divide it over. And x equals 2. Let's see if it works. If I plug in 2, 8 times 2 is 16. 16 minus 2 is 14. 2 plus 12 is 14. See? This side is the same as this side. They're both 14 in length. Like I said, the nice thing about geometry is that you can always check your work. Alright, next one. Pause the video, see if you can figure out what x is. And we're back. The equation is 2x plus 3 is equal to 4x minus 7. And the only reason I can use the equal sign is because that's a bisector, and this piece is equal to this piece. This side here is the same as this side. So you do your algebra, subtract the 2x, take this negative 7 and add it over there, take the 2 and divide it, and we check our work. Plug in 5. 5 times 2 is 10. 10 plus 3 is 13. 5 times 4 is 20. 20 minus 7 is 13. Alright, that's part 1 of the video. We'll do part 2